Welcome to this discussion video for Math 21, where we will be answering some exercises on the topic limits involving infinity. These include infinite limits and limits at infinity. Since this is a discussion video, make sure that you've already watched the lecture video for this topic before proceeding. So we will be evaluating the following limits. I encourage you to try answering them first on your own before continuing with the discussion. Before we start solving, I'm just going to give you a reminder. Most of the mistakes committed in solving problems in this topic happen when examining the behavior of a denominator approaching zero. Oftentimes, there is confusion on whether it approaches zero through positive values or negative values. So let's have a quick exercise on that. As x goes to 1 from the left, x minus 1 will approach 0 through. Values to the left of 1 are 0.8, 0.9, 0.99, and so on. And if we subtract 1, we get a very small negative value. So x minus 1 approaches 0 through negative values. Then as x goes to 1 from the right, x minus 1 will approach 0 through positive values because the values to the right of 1 are 1.1, 1.11, and so on. And if we subtract 1, we get a small positive value close to 0. Okay, now as x goes to negative 1 from the left, x plus 1 goes to 0 through. Values to the left of negative 1 are negative 1.2, negative 1.11, and so on. And if we add 1, we get a very small negative value close to 0. So x plus 1 approaches 0 through negative values. And lastly, as x goes to negative 1 from the right, x plus 1 goes to 0 through positive values, since the values to the right of negative 1 are negative 0.9, negative 0.99, and so on. And if we add 1, we get a very small positive value close to 0. So this is just a reminder to please be careful with your signs when evaluating limits. For number 1, we are asked to find the limit of 2x cubed minus 5x squared all over x squared minus 1 as x goes to 1 from the left. Observe that when we evaluate at 1, we get a constant number in the numerator while the denominator is 0. To answer this, we first write the denominator in its factored form. So this is equal to the limit of 2x cubed minus 5x squared all over. The factors of the denominator are x plus 1 and x minus 1, as x goes to 1 from the left. Now take note that the numerator goes to negative 3, x plus 1 goes to 2, and x minus 1 goes to 0 through negative values, as x goes to 1 from the left. We have a negative constant over a denominator that approaches 0 through negative values, and therefore the limit is positive infinity. In this item, we are asked to find the limit of the sum of two functions. Notice that the second term has a factorable denominator. So to solve this item, let's first write the second term in its factored form. So this will be equal to the limit of x over x plus 2 plus x minus 2 all over, the factors are x plus 2 times x minus 1, as x goes to negative 2 from the left. For the first term, x goes to negative 2 all over a denominator that goes to 0 through negative values. And for the second term, we have negative 4 all over x plus 2 goes to 0 through negative values, and x minus 1 goes to negative 3. So the limit of the first term is positive infinity, and the limit of the second term is negative infinity. This means that the limit is indeterminate of type infinity minus infinity. So we have to rewrite this in a form that will allow us to determine its limit. Since the terms have a common factor in the denominator, what we can do is combine the two terms into one using their least common denominator. So let's copy this. It will be equal to, the LCD is x plus 2 times x minus 1, and the numerator will become x times x minus 1 plus x minus 2. If we expand the numerator, we have the limit of x squared minus x plus x minus 2 all over x plus 2 times x minus 1 as x goes to negative 2 from the left. Simplifying, this becomes the limit of x squared minus 2 all over x plus 2 times x minus 1. In this form, the numerator goes to 2, x plus 2 goes to 0 through negative values, and x minus 1 goes to negative 3. So we have a positive constant in the numerator, and the denominator goes to 0 through positive values. So the limit is equal to positive infinity. For number 3, we need to find the limit of this function as x goes to 2 from the left. Observe that if we evaluate the numerator at 2, we get 0, and for the denominator, we also get 0. This is an indeterminate form, and again, we need to rewrite this function in a form where we can determine its limit. Observe that we have a radical function. We can solve this by multiplying the function by 1 using the conjugate of the denominator. So we have the limit of x minus 2 all over 2 minus the square root of 4x minus x squared times the conjugate of the denominator is 2 plus the square root of 4x minus x squared. Multiplying, this is equal to the limit of x minus 2 times 2 plus square root of 4x minus x squared all over, the denominator becomes 4 minus the quantity 4x minus x squared as x goes to 2 from the left. Take note that the denominator here is just the trinomial x squared minus 4x plus 4. So that in the next step, we write it in its factored form. So this is equal to the limit of x minus 2 times 2 plus square root of 4x minus x squared all over x minus 2 quantity squared. The numerator and denominator have a common factor of x minus 2, so this can cancel. So that we have the limit of 2 plus square root of 4x minus x squared all over x minus 2. We can cancel this because we know that x only approaches 2 and is not equal to 2. Now in this form, if the numerator is evaluated at 2, we have 2 plus the square root of 4, and the denominator goes to 0 through negative values. So we have a positive constant over a denominator that goes to 0 through negative values. Therefore, the limit is equal to negative infinity.